All right, so now we're going to get into how bone is actually formed. We're going to get into kind of the details, the steps of how bone is made. And there's two different processes that we're going to talk about with this, and we'll get into both in terms of fetal development, but we'll also look at postnatal bone growth, which means after birth. We'll talk about ossification, and bone remodeling. So, like, how do we constantly remodel the bones to allow for growth? And then we'll also talk about bone repair. So if you sustain an injury, right, due to a fracture, and then we'll talk about different types of fractures as well. All right, so let's talk about what is ossification, also known as osteogenesis. It's just the making of bone, right? Making bone. So we will form a bone, we'll go through ossification or osteogenesis in 4 different situations. One, we need bones to model during fetal development because we need to actually make bones. Number 2, we need to model bones during the postnatal development, so as we get older. So just normal development. We remodel bones in response to metabolic and mechanical stimuli. This means even like things like exercise can impact your bones remodeling. For the better, right? Exercise is usually for the better. And then remodeling can occur in response to a fracture, basically in response to an injury. So modeling, we're talking about making new bone. There was no bone there, now there is. Whereas remodeling, right, we're replacing it. We're going in, we're gutting it, right? We're putting new things in. Kind of like if you would remodel a house, you still have the same basic structure, but you're going in, you're pulling out the cabinets, you're pulling up the carpet, right? Putting something else in. So old bone is constantly being broken down by your osteoclasts. This is called reabsorption. And new bone is constantly being laid down by osteoblasts, called formation. We have this when the teeth move during like an orthodontial procedure. So if someone has like braces, remodeling will allow us to do that. So the whole reason that those even work is because of the remodeling process. It also means that you need to do it right, because if you don't do those procedures correctly, you can actually lose that bone and then not necessarily get it all back, which means people's teeth end up loose. But if you're going through an orthodontist, then you should be fine. Usually when people are worried about that, it's from like those kits that people buy and just like do at their house for like braces, like the Invisalign type thing that people, it's not Invisalign, but they'll like get the molds and like make them at their own house and do it like in 6 months. Not a good idea. Bone repairs, right? Obviously we can fix our bones after an injury because of remodeling. It's also going to allow us to maintain the blood calcium levels in our body fluids, in our blood, so we can maintain homeostasis there. And then we can change the stress lines as we need, right? Because if we are getting bigger, taller, wider, whatever, we need to be able to, those stress lines are going to move, and we have to remodel the bone in response. So we're still laying along those stress lines to give the bone strength. So let's talk about what happens early on. And when I say early, I mean as early as we can get, which is embryonic bone formation. So the first thing we're going to start with is a cartilage model. So we don't even start with bone. We start with cartilage. And then from there, osteoblasts will start putting in the osteoid and the mineral salts, resulting in the calcification of it, right? So we're getting that calcium, we're getting the hydroxyapatite in there. And it's now transitioning from cartilage to bone. We also have a few different types of cells helping here. So some mesenchymal cells are going to secrete collagen to create a scaffolding. Other mesenchymal cells differentiate to chondrocytes. So they'll become the chondrocytes to deposit cartilage. And then lastly, we have some that become fibroblasts, which will then continue to lay down collagen and then allow the osteoblasts to start building bone. There's also 2 different ways to go through this with these cells and whatnot, and that's intramembranous ossification and endochondral ossification. This just comes down to which bones are you forming. Intramembranous ossification, we're typically thinking of flat bones, So like the cranial bones, the mandible, the clavicles, and whatnot. Whereas endochondral, we're usually thinking long bones, so we're thinking of the like bones in your arms and your legs, right? So on and so forth. So let's talk intramembranous ossification. Again, this forms the flat bones in the skull and the clavicles, or your collarbones. We start with ossification centers that basically appear within the fibrous connective tissue membrane. Again, those mesenchymal cells are the ones that are differentiating, either laying down collagen as the framework or differentiating into like osteoblasts to be able to build bone. And the osteoid is going to be deposited like randomly around these blood vessels, which gives us that weird spongy kind of look. Now, endochondral ossification, this one we have our cartilage model. So chondrocytes, again, coming from those mesenchymal cells, form what kind of looks kind of sort of like a bone. It's like a rudimentary bone. And then we see we have a primary ossification center. This appears in the middle of the medullary cavity area, or what's going to become the medullary cavity, in the diaphysis. And you see how it spreads upward and downward. And then as we're doing that, we're going to be breaking down some of the bone to form the medullary cavity inside. We see a secondary ossification center start, and that's going to help with the epiphyses, right? And they have their own blood supply. Right where these two meet, where the epiphysis and the diaphysis meet, we still see some that will never really fully calcify. That's the epiphyseal plate. That's also known as your growth plate. So that will stay that way for a bit until you are fully grown, in which case then it can solidify. So we look at that epiphyseal plate. Again, this is going to stay cartilage, right? What we call the chondrocytes, right? And those chondrocytes are just going to go through mitosis. They're going to, keep dividing. And then osteoblasts make their way into that cartilage and start transforming it from cartilage to bone. But again, this is going to continue to happen until you reach adulthood. And once you're at adulthood, we don't need that cartilage there anymore, and we're just going to replace it with bone. So we go from an epiphyseal plate, which is like an actively growing site of bone for length, and we transform to an epiphyseal line where we can no longer lengthen, it's now solid bone. So bones have gotten longer using that process, right? We look back, like we get longer this way, but we also have to get wider, right? If you think about it, because imagine like a little tiny baby, right? If it were just to lengthen bones but never widen them, like we would all be super narrow, right? But that's not the case. We get wider as well, and that's good because we need to be able to handle the weight. We need to be able to handle gravity and whatnot. So we also need to thicken in terms of diameter. And so this is going to be the cooperative action between the osteoblasts and osteoclasts. Basically, we break down bone on the inside and lay new bone down on the outside. So it's almost like we're constantly kind of like pulling what's from the inside onto the outside. And just doing that over and over again, making that medullary cavity inside wider, but also making the bone, the compact bone ring going around it thicker as well. So we're going to basically pull from the inside, lay new bone down on the outside. Other things that can contribute to remodeling, again, mechanical stress, so like exercise. Exercise does help increase the density of your bones, and is something that is absolutely vital, and one of the reasons why we should all have at least somewhat of a regular exercising schedule. Also nutrition, right? For growth and remodeling to happen properly, we need to have good nutrition, which means we're getting enough calcium, we're getting enough phosphorus, we're getting enough iron, magnesium, manganese, right? Fluoride, copper, vitamin C, K, D, B12, and A, right? Those are all vital to that. And then we have adequate hormonal instructions as well. So things like growth hormone and insulin-like growth hormone Thyroid hormones, insulin, our sex hormones influence this. Calcitonin influences this. Calcitriol is going to influence this. And all the ones you see here in green, right, are going to help promote growth and density, whereas cortisol and parathyroid hormone will promote a reabsorption, which means a loss of density. If we have certain endocrine abnormalities, this can affect our bone growth and density. So to understand bone remodeling, we have to look at factors that are called rankle and OPG. These are the things that we use to build or break down bone. So when we're trying to absorb bone, we're breaking bone down, we're going to secrete a lot of what's called rankle. This is going to promote the osteoclasts doing their job, where basically they have some acids that will literally kind of eat away at the surface of that bone. And then when we want to build the bone, we have osteoprotegerin or OPG. This is going to remove that rankle. So now the osteoclasts don't have their signal anymore. So they automatically kind of shut down, right? They're not told to do anything, so they don't do anything. Estrogen is going to upregulate OPG levels, right? And so this is why sometimes you see, like, when someone is going through menopause and they do not produce estrogen the same way, that the risk of osteoporosis can increase, because we are no longer kind of shutting down the rankle, shutting down the osteoclast, so that reabsorption happens more than it should, and we don't have the formation happening in response. So most of the bone mineral is a calcium base. Remember that hydroxyapatite? It was like calcium was like 10 of the atoms in it. So we need calcium, and we can use bone to bank for that calcium, and then just basically pull from it when we need it, deposit when we have an excess, so that we can use it for things like the nervous system and the muscles. This is I'm going to go through this really quickly because this should be a review from endocrine, but when your blood calcium levels are low, your parathyroid hormone is going to be released from your parathyroid gland, and this is going to tell osteoclasts, break down bone, break down bone. We need that calcium in the blood, so pull it from the bone, put it in the blood. Whereas if the blood calcium levels are high, the thyroid secretes calcitonin. I like to remember calcitonin's job as it's putting calcium in the bones, and so this tells the osteoblasts to take calcium from the blood and deposit it into the bone by building bone matrix. Again, mechanical stress, again, it has the ability to alter strength. Weight-bearing activities, and it doesn't need to be crazy. You don't need to be doing some Olympic crazy weightlifting things. Even something like walking helps build and retain bone mass. So exercise, especially weight-bearing activities, helps you retain and build more bone and increase density. This is especially important for us as we get older, because everyone who gets older is going to have to fight against bone loss, right? When you remove that mechanical stress, you actually weaken the bones. So someone who is like an astronaut, when astronauts return down, because they don't do a lot of weight-bearing activities up there, they actually do lose bone density. In fact, something that astronauts have to do, they actually have to kind of mimic weight-bearing activities. And so they do what they can, but it's still not the same as being on the planet. So they will still lose bone density when they come back down. Now, how do we fix bone, right? Because many of us may have this issue where we fracture a bone. And so there's a few different, steps to this process to fixing it. You may have heard of 3 or 4 different phases to this. We're going to break it into 3 phases, but overall just remember, what are the basic steps? The first is the reactive phase, or the inflammatory phase. This is what's going to happen immediately. The break has just happened that day. And so that's going to be, the first thing that's going to happen is we're going to have blood vessels that break, because remember, blood vessels run through bone too. And so if the bone breaks, blood vessels are going to break too. So we end up with a hematoma, right? Blood is going to collect there, and we're going to have a kind of you're going to have to form like some clots and whatnot to stop that from happening. So this usually happens in the first couple hours. Then we go into the reparative phase, and this one is where you might have seen it broken down into 2 separate steps because one of these has to happen before the other. But we're going to start to form calluses in the reparative phase. First, though, we have to form what's called a fibrocartilaginous callus or a cartilaginous callus. Right? You may have just seen it called cartilaginous. But we lay down cartilage to form a callus where the break has happened. Then we go through and form, replace that cartilage with bone to form a bony callus. So we go cartilaginous callus is now transformed to a bony callus. And again, sometimes you'll see these 2 steps split into 2 separate steps. I don't care if you remember it being 3 or 4 different phases, as long as you can tell me what is basically happening right throughout this process. And then last we get to remodeling, where we're just remodeling to get a more normal appearance, where any little bumps and divots and all that kind of stuff from the callus are smoothed over. We'll still see a little bit of not like a scar, but we will see a little bit of a remnant. It'll never fully disappear, so we would be able to tell in some cases that someone's broken something before, but it would be it'd be way smoother compared to when we have the callus. So let's take a peek at some of the different types of fractures. We have the open one, or a compound fracture. This is where the bone is broken and it is sticking through the skin. Opposite of that would be a closed fracture where everything is contained within the skin. Then we have comminuted. This is where the bone has been splintered, crushed, or broken. So we have little tiny fragments, and we're going to have to figure out what to do with all those itty bitty fragments between the 2 main pieces. We have a green stick. This is a partial fracture where one side is broken, the other side is bent, kind of like if you were to break a twig, but it didn't break all the way. So we pretty much see this in kids because their bones have not fully ossified, so they still have some more of that cartilage. We have impacted. This is where one end of the bone is forcefully driven into the interior of the other. So think of it almost like it's being crushed into itself, like you're crushing a can. We have a poct, which is in the distal end. So this is what we see in an ankle. Then the colles, this is going to be a fracture of the distal end of the forearm, the radius. There's a few other different types too, but we're not going to worry too much about that. And quite honestly, I'm not super worried about you memorizing a bunch of different fracture types. So, you can this is more of an interesting part than anything else. But knowing how bone is formed and how bone is remodeled or repaired, definitely need to know that.